Before running the code, it is imperative to know how it operates. The majority of the code is based on 4 created functions. The first 2 are quite simple, while the other 2 need more explanation. Intake spins the intake motor until the optical sensor at the base of the claw detects a tri-ball. Outtake spins the outtake motor until the optical sensor at the base of the claw loses detection of a tri-ball. Pusher front grabs an A and B value from a 2D list in the once-started event, which acts as the XY coordinates for the target of the robot. By using the distance formula, with the 2 points being the GPS, position of the robot and your target, we can calculate the distance from the robot to the target, which is stored in a hypotenuse variable. The distance formula works because it is based on imagining the robot and target forming a right triangle, and this same fundamental concept is what helps derive the angle formula. Using the 2-argument arctangent function, which finds the angle by calculating the arctangent of the imagined right triangle, we can obtain the angle that the robot must go in order to meet the target. This value can be stored in a variable named angle. Keep in mind that the angle formula uses an absolute value though, since the plane the robot is on has a domain and range spanning -1800 to +1800. Now that the hypotenuse and angle have been determined, the code runs a bunch of conditional statements which determines the robot's relation to the target. This is important because the robot might need to turn 30 degrees to the left instead of 30 degrees for the right, for example. The final function is claw front, which acts similarly to pusher front except with 2 differences. Firstly, the robot needs to turn 180 degrees extra to face the opposite direction, and secondly, needs to move forward instead of backwards to move the same perceived direction. Now that the code is understood, the code can be seen in action. Before any movement happens with the robot, the code sets up a 2D list which will be used for the pusher front and claw front functions. It also sets all motor velocities to 100% for maximum speed. Next, the preload is launched into the goal. After that, the robot goes to the center PVC pipe and starts placing all of the tri-balls into the red goal. This normally would take a lot of hard coding to write, but the use of functions is limited to a repeat loop containing 5 blocks. Once all of these balls are scored, the robot crosses over to the blue side, grabs the green tri-ball in the middle line, and pushes the red preload into the blue goal. After this, it throws the grabbed green tri-ball into the red goal, and goes to the corners and starts throwing tri-balls. Once again, a lot of space is saved by the use of a repeat loop that uses only 7 blocks, a lot less than what it would take to hard code. The program ends with 60 points with 7 seconds remaining. VR skills taught us a lot about coding and how much better a script can become when functions and algorithms are used in place of hard coding. The usage of sensors, variables, conditionals, and loops drastically improve the consistency, runtime, and accuracy of our code. In competition, our newly acquired skills can help us create consistent code for the autonomous period, which would greatly help in winning competitions. VR skills also taught us problem-solving skills, which can help us in all facets of life.